Hello, welcome back to the Geog 300 Geographical Data Analysis video series for WVU. We have been working through, as you know by now, samples and properties of samples. I said at the outset, the whole point of wanting to do this and with inferential statistics is to relate sample statistics, understanding and processes about our sample, and try to infer that what we know about the sample will also hold true about the population. And we will then look at, within these last few videos, both an example of this and how to kind of reason with that, and looking at especially different summary or descriptive statistics of the population versus the mean, or versus the sample within the focus of the mean. So we will know from our sample, from our measurements, the sample mean and the population mean. We know the sample mean and the sample standard deviation. And I'm using the book here to just make sure that I get all of the terms and the symbols correct. If you see an X with the bar over it, that's referring to the sample mean. And S will refer to the sample standard deviation. If you are working, especially in Excel, if you've gone and you look at the standard deviation formula, you will notice there is STDEV.S if you're working with the sample, versus a population. In inferential statistics, it's not always the case, but in inferential statistics, we don't know the population values. That's kind of the whole point of this sampling procedure. We cannot get the population values. So, acknowledging that, we have actually different symbols. The population mean is represented with the Greek letter mu, and a lowercase Greek sigma for the population standard deviation. In a case where it's known, it's actually calculated slightly differently than the sample one, so it's actually a different formula in Excel. STDEV.P versus .S for population and sample, respectively. What we are doing, and as I said, with the mean, so we might go and say, what is the average of, say, to take that farmer example, what is the proportion or the average, just really simple, the average age of the farmer. I get my sample, I know the mean, I can get the sample mean age, and I can calculate the standard deviation of those ages. I might want to be making some kind of understanding about the population age, but I don't know that. There are, however, using this idea of sampling precision, we can then relate these two values to this unknown value if and only if, through sampling accuracy, we can assume our sample is representative. So the next video will show that process, something called the central limit theorem, of how we can relate these known values to this unknown value, but that's really what we want to try to figure out. So with that in mind, I will see you at the next video.